Okay guys, welcome back. So in the last video I explained to you and I finished explaining to you about the concept of long division. So long division is all about the concept of dividing functions of any degree, whether it's square, quadratic, cubic or quartic or anything of division. So in this video I'll be focusing on the remainder theorem. So what is remainder theorem and why is remainder theorem important? Now you know that when I divide x squared, then now when I divide this one, let's take the same example. When I divide 3x to the power 4 plus 7x cubed minus 6x plus 2 by x plus 1, my remainder will be finally 12. But do we require to go through all these steps? Do we require to go through all these steps to find the final answer? So that is the key to remainder theorem. So remainder theorem explains a simple way, a one-step way, to be short, of finding the remainder of a given function when it is divided by another function. So example, when you divide this function by this function, you can, through the remainder theorem, you can directly get 12 rather than going through all these steps. Because this is at on one thing, this time consuming, and when you solve this equation of like this, sometimes this may cause errors. So to minimize all this, you need remainder theorem, and remainder theorem is something like this. So the remainder theorem explains that if a polynomial, so polynomials you understood on the theory on functions I explained to you. So if you have a polynomial named fx, and if this polynomial is divided by x minus k, now understand this one. So if you have some positive here, so if you have say x plus k, what you do is you have to write this one as x minus k, right? So this is also equal to fx divided by x minus k in the case of positive ones. In the case of x plus k, you have to write this one as x minus k. However, when you divide this one, fx by x minus k, the remainder is equal to fk. So let's take, so this is about the remainder theorem. So let's take a simple example to elaborate this concept. So say that if you are given some function like this, fx is say 2x cubed plus 5x squared plus 6x plus 8, right? So that if you want to find the remainder when you divide this function fx by following terms, x minus 1, x minus 2, x plus 1 and x plus 2, right? X plus 1 and x plus 2. So there are actually 4 answers that you need to obtain here. So my first objective will be to find the remainder when I divide fx by x minus 1. So you know that fk is actually the replacement of x with k. So when I divide fx by x minus k, what I'll do is that I'll replace this x with k to get fk. So my remainder will be fk. So x minus 1 is in the form of x minus k, where k is equal to 1. So when k is equal to 1, you can say that the remainder when fx is divided by x minus 1 is equal to f1, because you know that when fx is divided by x minus k, the remainder is fk. So if k is equal to 1, the remainder will be f1. So what I do is f1. So f1 is actually the substitution of 1 for this equation or for this function where x is concerned. So substituting x here, you can say that this is equal to 2 times. So x cube is 1 cube plus 5 times 1 square plus 6 times 1 plus 8. So this will be 2 plus 5 plus 7, 13, and 13 plus 8 will be 21. So similarly, when you divide 2x cubed plus 5x squared plus 6x plus 8 when you divide by x minus 1 through long division or any other process, you should get this answer. So that's why I said this is a very easy process, just a simple step. You need to find what is the value of k, and you to substitute solve it, and just within a single step of solving you can get the value of the remainder. So when I get when I need to find the value of x minus 2, this is in the form of x minus k, where k is equal to 2. So k is equal to 2. When k is equal to 2, the remainder will be f2. So f2 is actually the substitution of 2 in place of x in this function of fx. So that will be 2 times 2 cubed plus 5 times 2 squared plus 6 times 2 plus 8. So 2 cubed is 16, 16 times 2 is 32, and here will be 2 squared is 4, 4 times 5 is 20. So here is, here will be 16, right? Sorry, 2 times 8 is 16, here will be 5 times 4 is 20, so 16 plus 20 is 36, 36 plus 12 is 48, 48 plus 8 is 56. So the remainder, when I divide this term fx by x minus 2, will be 56. Similarly, now you know that when I divide by x plus 1, as I mentioned here, when I divide by a positive value, what I do is that I have write this function as x minus the minus value. So x plus 1 is also equal to x minus minus 1, and x plus 2 is equal to x minus minus 2. So for this function, when I divide by this one, k will be equal to minus 1. So k is equal to minus 1. So the remainder, when I divide fx by x plus 1 or x minus minus 1, will be f minus 1. So I substitute minus 1. So that will be 2 times minus 1 cube plus 5 times minus 1 squared plus 6 times minus 1 plus 8. Okay. Plus 8. So what I will do is that this is also equal to, now 2 times minus 1 cube is equal to minus 2, minus 1 square times 5 is equal to positive 5. So here will be minus 6, and here will be plus 8. So that will be 5 plus 8 is 13. 13 minus 8 is equal to 5. So the remainder, when I divide fx by x plus 1, will be 5, right? So as the next step, what I do is that when I divide this function by x plus 1, right? When I divide this function by x plus 2, what I'll remain is that similarly f minus 2, right? F minus 2. So that will be 2 times minus 2 cube. So minus 2 cube is actually minus 8. Minus 8 times 2 is minus 16. Minus 2 square times 5 is 4 times 5 is 20. So that will be minus 16 plus 20 will be plus 4. So that will be, I have another positive 6 times minus 2, which is minus 12. So plus 4 minus 12 is equal to minus 8, plus 8 is equal to 0. So you will get, when I substitute f minus 2, as f minus 2 is 0, so you will learn in the next video that when I divide something by some term, if you get a remainder of 0, that it is a factor of that. So in the next video I will be talking about the factor theorem. So this example in which we get f minus 2 is the introduction to factor theorem. So in this video I explained to you about the remainder theorem. So in the next video I will be talking about the factor theorem, and see you then.